Hi cbse11 students. This is annuity topic, chapter number 14. Now in our previous video we already discussed that annuity due case of future amounts. Now in this video we will learn that same due case, but we are dealing in this video for the present values. So the present value, or it is also called capital value of annuity due. I already told you in my previous video and other videos, a due case means you have to start your payments from the initial stage. That means from the today you have to start your payment. Okay, so that is called due case. Now look at this diagram. In this diagram you will see a line, horizontal line, naming that 0 time period, first time period, second and third and so on, n-2, n-1 and n. Okay, so that means from 0 to n. This was the term actually. Term means, you know, from the definitions it was a starting date of and ending date of that loan time or whatever it is. Now we are starting payments from today. That means it was a fixed amount that is called payment, or you can also call it as capital R. We denoted with R, this payment. So R will be same, and for the first payment, the interest, the amount you will earn is R into 1 plus I. So for present value it will be R by 1 plus I. It's reciprocals. Okay. In the same manner, for the second term you will earn the present value of for the second term will be R by 1 plus I whole square, and so on. And at last you will earn that R up to n-1 payments. So R by 1 plus I power n-1. And you know that the last payment we are not paying. This is why, because it's a due case. Now, so for getting present value, we will add all these present values together. So the first number R here, next number R by 1 plus I, R by 1 plus I whole square, and so on, R by 1 plus I power n-1. Okay. Now clearly it was a geometric progression. So look at that progression. It was a geometric progression. R is entirely a common factor, and the first term will be 1, and common ratio will be 1 by 1 plus I. Okay. So if you are not taking that R as a common factor, then R will be the first term, you know that from the geometric progressions. So A equal to R and small r will be 1 by 1 plus I. So using geometric sum of geometric terms, P equal to R of, that means A of 1 minus R power n by 1 minus R. We learn that in the sequence and series in geometric progressions. So this is R and this is A. So this is a reciprocal term, so we can write this as 1 plus I whole power minus n. And just do LCM here. The denominator of denominator, this 1 plus I become multiplier of this R in this step, and 1 minus 1 plus I power minus n minus 1 plus 1 got cancelled, I will be in the denominator. Now this is the formula for present value due. Okay, and for the annuity tables, we will use just multiply this 1 plus I to these numbers, and your doubt will be arise in your minds that why we are multiplying, because you have to kept r only, not 1 plus I besides of this r. So we are doing multiplication with this 1 plus I to the terms of in this bracket. So r will be required, not else. So 1 plus I into I will be 1 plus I. So 1 plus I into 1 plus I power minus n, it will be 1 plus I power minus n plus 1. So if you take minus as a common term, then you have n minus 1. Now just divide this I got cancelled one time and 1 by I. So the remaining terms. So this one and these terms are separated like this, and I by I written as a 1. Okay, now 1 plus, we will, for present values we are using small a in using annuity tables. Remember this formula. This is also one of the formula you have to remember. So present values we are using representing this term as a n minus 1 by I, where n minus 1 is a power of this 1 plus I, and I is a rate of interest. Okay, this representation is also very important. Okay, got it? The present value. Thanks for watching. Don't forget to subscribe this channel to get more updates. Thank you very much.